40 Most Amazing Things Seen in Kuiper Belt. Hello everyone, welcome to Space Explorer channel. The Kuiper Belt is a vast region of our solar system beyond the orbit of Neptune, filled with countless icy objects and remnants from the formation of our solar system. It has only been fully explored in recent years, thanks to advancements in space technology. As we continue to uncover more about this mysterious area, we are constantly amazed by the incredible sights it has to offer. From dwarf planets to fascinating moons and stunning formations, the Kuiper Belt is truly a treasure trove of wonders. In this video, we will take a look at the 40 most amazing things that have been seen in the Kuiper Belt, giving us a glimpse into the incredible diversity and beauty of this distant region of our solar system. Before moving forward, if you are new to our channel, please don't forget to like and subscribe our channel for future interesting videos. 1. Pluto, the former ninth planet. The tale of Pluto, the former ninth planet of our solar system, is as fascinating as it is poignant. Discovered in 1930 by astronomer Clyde Tombaugh, Pluto held its planetary status for 76 years before it was reclassified as a dwarf planet by the International Astronomical Union in 2006. But don't let the dwarf prefix fool you. There's nothing diminutive about the significance of this Kuiper Belt object. Dwelling in the farthest corners of the solar system, approximately 3.6 billion miles from the Sun, Pluto is a celestial body teeming with surprises. One of the most intriguing aspects of this dwarf planet is its size, being smaller than Earth's moon, yet possessing a multi-layered atmosphere, a rarity for celestial objects of its kind. This exotic atmosphere, made of nitrogen, methane, and carbon monoxide, undergoes extraordinary transformations, freezing onto the planet's surface during its farthest point from the Sun and evaporating into gas as it approaches closer. 2. Charon, a moon with personality. Sitting comfortably in the vast expanse of the Kuiper Belt, alongside its parent body Pluto, is Charon, the largest of Pluto's 5 known moons. This moon, named after the mythological ferryman who transported souls across the river Styx, boasts an impressive array of features and idiosyncrasies that truly bring its personality to life. First discovered in 1978, Charon quickly distinguished itself from the other moons due to its size. With a diameter of about 750 miles, it's not just the biggest moon in Pluto's system. It's also the largest object in the solar system relative to its parent body. So much so that it doesn't actually orbit Pluto in the traditional sense. Instead, both Charon and Pluto revolve around a shared center of gravity, a characteristic usually attributed to binary star systems. This unique arrangement earned Charon and Pluto the title of a binary planet system, a rarity in our solar system, and an intriguing spectacle for astronomers worldwide. 3. Hamia's peculiar shape. Amid the myriad of objects swirling in the icy fringes of the Kuiper Belt is Hamia, a dwarf planet whose bizarre shape sets it apart from the rest. Named after the Hawaiian goddess of childbirth, Hamia's elongated, egg-like form has drawn the attention of astronomers and sparked considerable interest in its formation and properties. Hamia is the most rapidly rotating large body in our solar system, completing a rotation in just under 4 hours. This fast rotation, combined with its internal composition, believed to be a mix of rock and ice, has led to Hamia's intriguing and somewhat comical shape. Imagine a planet-sized rugby ball or a giant cosmic egg spinning wildly in the cold depths of the Kuiper Belt, and you've pretty much visualized Hamia. 4. Makemake, a reddish dwarf planet. As we delve deeper into the intriguing inhabitants of the Kuiper Belt, we come across another fascinating member of this icy realm, Makemake, a dwarf planet that commands attention due to its reddish hue and mysterious solitary nature. Makemake, pronounced M-A-K-M-A-K, was first spotted in 2005 and later designated as a dwarf planet in 2008, named after the creation deity of the Rapa Nui people of Easter Island. Makemake adds to the diversity and intrigue of the Kuiper belt with its unique characteristics. One of the first things that catch your attention about Makemake is its reddish hue, a color not commonly seen among celestial bodies. The reddish color of Makemake is thought to be due to the presence of complex organic molecules known as tholins on its surface. These tholins are formed when cosmic rays and solar ultraviolet light interact with simple organic compounds like methane. And while this reddish color may be an eye-catching attribute, it's what it signifies that's truly captivating. 5. Eris, catalyst for planetary reclassification. As we venture further into the enigmatic Kuiper belt, we encounter Eris, a dwarf planet that has not only challenged our understanding of celestial bodies, but also played a crucial role in redefining what it means to be a planet in our solar system. Eris, named after the Greek goddess of discord and strife, certainly lived up to its moniker when it was discovered in 2005. This icy world, located in the scattered disk region of the Kuiper belt, is notably larger than Pluto, a fact that sparked a fiery debate within the astronomical community. Could our solar system accommodate a 10th planet? Or did this discovery require us to rethink the definition of a planet altogether? 6. Quaoar, early discovery in the Kuiper belt. As we voyage deeper into the captivating cosmos of the Kuiper belt, we find ourselves in the company of Quaoar, pronounced Quaoar, a notable object that predates most discoveries in this icy frontier. Unearthed in 2002 by astronomers Michael Brown and Chad Trujillo, Quaoar's discovery served as a significant precursor to the later discoveries of many more dwarf planets and objects in the Kuiper belt. Distinguished by its size, Quaoar is an impressive world, spanning about 780 miles in diameter, making it roughly half the size of Pluto. This considerable size earns Quaoar the classification of a cubeano, a large Kuiper belt object in a near-circular orbit around the Sun, unswayed by the gravitational influence of Neptune. 7. Diverse surface compositions. As we delve deeper into the awe-inspiring wonders of the Kuiper belt, we encounter a display of diversity that extends beyond the unique attributes of individual objects and reaches into the very fabric of their being. Their surface compositions, the celestial bodies inhabiting this icy frontier of our solar system, may appear as remote, cold, and desolate worlds, but a closer look reveals a riot of variety in their surface makeup that is nothing short of breathtaking. One of the remarkable things about the objects in the Kuiper belt is their individuality when it comes to surface compositions. Each object, whether it's a dwarf planet, a moon, or a small body, possesses its own unique combination of ices, rocks, and other materials. This diversity tells us a lot about the history and possible future of these bodies, offering clues about their formation, geology, and the physical and chemical processes shaping their appearances. 8. Varying sizes of Kuiper belt objects. The Kuiper belt, our solar system's final frontier, is a veritable showcase of celestial bodies of various sizes, from small chunks of rock and ice barely a few kilometers across to colossal dwarf planets rivaling the size of their larger planetary cousins. This remarkable range in size not only speaks to the diversity of the Kuiper belt, but also offers valuable insights into the formation and evolution of our solar system. At one end of the size spectrum, we have tiny objects often referred to as KBOs, or Kuiper belt objects. These are essentially small chunks of rock and ice, with diameters typically less than 100 kilometers. Often remnants from the early solar system, these KBOs serve as cosmic fossils, preserving the raw materials that went into the making of planets and moons. 9. Binary systems in the Kuiper belt. Binary systems, an exotic celestial phenomenon, add a fascinating dimension to the remarkable array of objects inhabiting the Kuiper belt. Typically associated with stars, binary systems are characterized by two celestial bodies of comparable size, orbiting around a common center of gravity. Such systems in the Kuiper belt, however, add a new layer of complexity. involving not stars, but icy objects, dwarf planets, and moons. The concept of binary systems may sound intricate, but their essence can be explained quite simply. Imagine two celestial dance partners, equally matched in size and mass, spinning around each other in a cosmic waltz. Their dance floor is not a physical entity, but a point in space referred to as the barycenter, the common center of mass around which both objects orbit. 10. Creo Volcanism. Icy eruptions in the cold depths. Our journey through the astonishing wonders of the Kuiper belt wouldn't be complete without a detour into the fascinating world of cryovolcanism, a process that breathes life into these icy celestial bodies. Cryovolcanism, also known as cold or ice volcanism, is a form of volcanic activity where the eruptions involve volatile substances such as water, ammonia, or methane, rather than molten rock. Imagine a volcano, but instead of spewing out lava, it ejects a slurry of icy particles and gas, painting a picture as enchanting as it is alien. Cryovolcanism is not just a captivating phenomenon. It's also a crucial player in shaping the surfaces of many Kuiper belt objects and keeping their geological stories alive. In contrast to regular volcanism, which relies on a body's internal heat to melt rock, cryovolcanism requires much less energy to ignite. In the frigid depths of the Kuiper belt, where temperatures plummet far below freezing, this icy form of volcanic activity offers a more feasible way for bodies to exhibit geological dynamism. 11. Unique orbital characteristics. Prepare to be dazzled as we delve into the captivating subject of unique orbital characteristics. Imagine stars, planets, asteroids, and comets, each following a set path, guided by the force of gravity. Now picture these paths not as simple circles, but as a complex array of orbits, elliptical, parabolic, hyperbolic, each carrying its own fascinating narrative. To start, let's think about what an orbit is. An orbit is essentially the path an object takes as it moves around another object in space due to the force of gravity. The Earth, for example, orbits the Sun in an elliptical path, while the Moon follows a slightly irregular path around the Earth. But not all orbits are as straightforward. Some celestial bodies, like comets and asteroids, follow highly elliptical or parabolic orbits, slingshotting around the Sun at high speeds only to be flung back out into the outer reaches of the solar system. Others, like the planets in our solar system, maintain more regular, nearly circular orbits. 12. Scattered disk objects. Beyond the Kuiper belt. As we journey beyond the Kuiper belt, we enter the mysterious realm of scattered disk objects, SDOs. These celestial nomads roam the outermost reaches of our solar system, their orbits nudged into elongated and highly inclined trajectories by gravitational interactions with the giant planets. Take Eris, for instance. Dubbed the most massive and second largest dwarf planet in the known solar system, Eris is a scattered disk object orbiting in a region of space known as the scattered disk. This region is a veritable Wild West of the solar system, filled with objects like Eris that follow eccentric orbits, reaching distances as far as 100 times that of Earth from the Sun. 13. Trans-Neptunian objects, TNOs. Our cosmic adventure continues with a foray into the fascinating realm of trans-Neptunian objects, TNOs. TNOs are a variety of celestial bodies located in the icy expanses beyond Neptune's orbit, a region often referred to as the trans-Neptunian region. This region, filled with a cornucopia of celestial bodies, is like an echo of the early solar system, revealing insights into its birth and evolution. TNOs are a mixed bag, varying wildly in size, shape, and composition. 14. Kuiper belt debris, source of comets. Next up on our cosmic journey, we venture into the captivating arena of the Kuiper belt, a region of space brimming with small celestial bodies known as Kuiper belt objects, KBOs. In this distant realm, nestled beyond Neptune's orbit, An icy debris field takes center stage as the source of many comets. Picture the scene. Countless chunks of ice and rock, remnants of our solar system's formation, hurtling around the sun in a chaotic ballet. This is the Kuiper Belt, a vast frontier filled with ancient celestial debris, each piece narrating its own story of the solar system's early years. It's akin to an open book, offering glimpses into the past that shaped our present. 15. New Horizons Mission. Unveiling Pluto's secrets. As we continue our celestial journey, we find ourselves delving into the thrilling saga of the New Horizons mission. Launched in 2006, this pioneering expedition's primary goal was to explore Pluto, the erstwhile ninth planet in our solar system, and now the largest known trans-Neptunian object. New Horizons, a robotic spacecraft traveling at breathtaking speeds, embarked on a 9-year journey across the vast expanses of our solar system. During this voyage, it captured stunning images and vital data about Jupiter and its moons, but the crown jewel of the mission was the close encounter with Pluto. 16. Hubble Space Telescope Observations. As our cosmic exploration presses onward, we set our sights on the invaluable contributions of the Hubble Space Telescope. This titan of astronomical observation has provided stunning insights into the cosmos, its gaze reaching into the most remote corners of our universe. Consider the role of the Hubble in our understanding of the Kuiper Belt. By studying the colors and brightness variations of these distant objects, the Hubble Space Telescope has provided vital clues about their composition and origin. 17. Kuiper Belt Object Colors. Clues to composition. Let's take a moment to marvel at the vibrant color palette of the cosmos, specifically focusing on the colors of the Kuiper Belt objects, KBOs. You might wonder how color can be an intriguing factor in space exploration. Well, hold on to your space helmets, because the colors of KBOs are actually a wealth of information, providing fascinating clues to their composition and history. Every celestial object in our universe tells a tale, and it does so not just with its size, shape, or orbit, but also with its color. 18. Potential for Planet 9. Buckle up, space enthusiasts, as we delve into the exciting realm of Planet 9, a hypothetical planet proposed to exist in the outer reaches of our solar system. This elusive celestial body is yet to be discovered, but its potential presence could potentially unravel new intriguing facets of our cosmic neighborhood. Imagine a world lurking beyond the known boundaries of our solar system, a planet estimated to be up to 10 times the size of Earth. That's the fascinating concept of Planet 9. Its existence was first suggested in 2016 based on unique orbital anomalies observed in several distant trans-Neptunian objects. 19. Kuiper Belt Object Surveys. Mapping the Unknown. Brace yourself for a fascinating ride as we zoom into the realm of Kuiper Belt Object Surveys. These cosmic expeditions have the monumental task of mapping the unknown, cataloging the countless icy bodies that reside in the Kuiper Belt, beyond Neptune's orbit. It's akin to navigating the celestial treasure hunt, where every discovery adds a new piece to the cosmic jigsaw puzzle. Each survey, carried out by observatories on Earth or space telescopes, captures snapshots of distant KVOs. These snapshots provide a wealth of data: size, shape, color, brightness, and more importantly, their orbits. In other words, these surveys provide us with a roadmap to this icy frontier. 20. Distant flyby targets for New Horizons. Strap in as we set a course to the farthest corners of our solar system, aiming our sights on the distant flyby targets of NASA's New Horizons mission. This trailblazing journey, deep into the celestial wilderness, aims to unravel the mysteries of our solar system's remote inhabitants. After its incredible rendezvous with Pluto, New Horizons set course for a new target, a small Kuiper Belt object, KBO, known as Arrokoth. The spacecraft sped past this icy world on January 1, 2019, providing a wealth of data and stunning images. This contact binary, composed of two joined bodies, offered fresh insights into the early stages of planetary formation. Beyond Arakoth, the journey continues. New Horizons, powered by a supply of plutonium-238, has enough energy to carry out another Flyby mission, provided a suitable target can be located within its path. The quest for this next target is an exciting chapter in the saga of New Horizons, a testament to our unquenchable thirst for exploration and knowledge. 21. Kuiper Belt Object Occultations, Celestial Shadows. One of the most fascinating aspects of Kuiper Belt objects is their ability to cause celestial shadows through occultations. These events occur when a KBO passes in front of a star, causing its light to dim for a brief moment. These seemingly small events provide valuable insight into the origins and dynamics of our solar system. By studying the timing and duration of these occultations, scientists can determine the size and shape of KBOs, as well as their orbits and positions. It's amazing to think that these celestial shadows hold the key to unlocking some of the universe's greatest mysteries. 22. Kuiper Belt Object Families. Common Origins. Kuiper Belt objects are not a homogeneous group, but rather a collection of families with diverse characteristics. Scientists believe that these objects share a common origin, likely formed in the outer reaches of the solar system during the early stages of its formation. By studying the composition and properties of these KBO families, we can gain insight into the physical and chemical conditions of the early solar system. It's fascinating to think that by studying these distant objects, we can uncover the mysteries of our own cosmic origins. 23. Kuiper Belt and the origins of the solar system. The Kuiper Belt is a treasure trove of information about the origins of our solar system. By studying the composition and dynamics of these distant objects, scientists have been able to piece together a picture of the early solar system and its evolution over time. It's fascinating to think that the Kuiper Belt, once thought to be a barren wasteland, is actually a rich source of information that can help us understand the mysteries of our own cosmic origins. So next time you gaze up at the stars, remember that those distant celestial shadows hold the key to unlocking some of the universe's greatest secrets. 24. Kuiper Belt Objects and the Late Heavy Bombardment. The Late Heavy Bombardment, LHB, was a period of intense asteroid and comet impacts on the inner planets that occurred about 4 billion years ago. While the exact cause of the LHB is still debated, Kuiper Belt objects are believed to have played a role. By studying the size and distribution of KBOs, scientists can better understand their gravitational interactions with the outer planets, which may have led to the destabilization of comets and asteroids and the subsequent bombardment of the inner solar system. The Kuiper Belt objects may hold the key to unlocking the mysteries of this cataclysmic event in our solar system's history. 25. Kuiper Belt Object Rotation Rates. Have you ever wondered how fast Kuiper Belt objects rotate? Well, scientists have been studying the rotation rates of these distant objects and have made some fascinating discoveries. Some KBOs rotate so slowly that a single rotation can take hundreds of years, while others spin so fast that they complete a rotation in just a few hours. By studying the rotation rates of these objects, scientists can gain insight into their composition, shape, and internal structure. It's amazing to think that these distant celestial bodies can tell us so much about the mysteries of our own solar system. 26. Kuiper Belt Objects and Exoplanet Research. The study of Kuiper Belt objects is not only relevant to our understanding of our own solar system, but can also provide insight into exoplanet research. By studying the properties and dynamics of KBOs, scientists can better understand the formation and evolution of planetary systems beyond our own. This knowledge can help us identify and study exoplanets with similar properties to those in our own solar system, ultimately leading to a greater understanding of the universe and the possibilities of extraterrestrial life. The study of Kuiper Belt objects truly opens up a whole new world of discovery. 27. Kuiper Belt, and the formation of the Oort cloud. The Kuiper belt may have played a crucial role in the formation of the Oort cloud, a hypothetical cloud of icy bodies thought to surround our solar system at a distance of up to 100,000 astronomical units. By studying the dynamics of KBOs and their gravitational interactions with the outer planets, scientists can better understand the processes that led to the formation of this distant cloud. The study of Kuiper belt objects offers a window into the complex and fascinating evolution of our solar system and the mysteries that lie beyond. 28. Kuiper belt object dynamics. Gravitational interactions. The dynamics of Kuiper belt objects are governed by gravitational interactions with the outer planets. By studying these interactions, scientists can gain insight into the formation and evolution of our solar system. These interactions can also cause changes in the orbits of KBOs, leading to fascinating phenomena, such as resonances and resonant trapping. The study of Kuiper belt object dynamics allows us to better understand the complex and dynamic nature of our solar system and the role that these distant objects play in its evolution. 29. Kuiper belt object light curves. Changing brightness. Kuiper belt object, KBO. Light curves are a fascinating phenomenon. These objects are not just static bodies in space, but rather dynamic entities that change in brightness over time. By studying these changing light curves, scientists can gain valuable insights into the composition, shape, and rotational properties of KBOs. This information helps us understand the evolution of our solar system and the processes that have shaped it over time. It's amazing to think that by analyzing the changing brightness of these celestial bodies, we can uncover the mysteries of the universe's distant past. 30. Kuiper belt objects and solar system evolution. The study of Kuiper belt objects provides valuable insights into the evolution of our solar system. By studying the properties and dynamics of these distant objects, scientists can piece together a picture of how our solar system formed and evolved over time. From the late heavy bombardment to the formation of the Oort cloud, KBOs offer a window into the complex and fascinating history of our solar system. By unlocking the mysteries of the Kuiper belt, we can gain a greater understanding of our place in the universe and the processes that have shaped it over billions of years. 31. Kuiper belt object orbits and the NICE model. How did the outer solar system evolve? The NICE model has been developed to explain the current state of the Kuiper belt and how it came to be. Essentially, the model suggests that the giant planets underwent a period of orbital instability that caused Uranus and Neptune to swap places, and Jupiter and Saturn to migrate outward. This event caused the Kuiper belt to form and objects to be scattered into new orbits. Through computer simulations and observations, scientists are working to confirm the NICE model's validity and uncover more about the Kuiper belt's past and present. 32. Kuiper belt objects and the Kuiper cliff. The Kuiper cliff is a fascinating phenomenon that refers to the sudden decrease in the number of Kuiper belt objects beyond a certain distance from the Sun. It is thought that the gravitational influence of Neptune is responsible for this cliff, as it acts as a barrier preventing objects from moving further out. However, recent research suggests that there may be more to this cliff than we previously thought. Some scientists believe that the presence of another massive object in the outer solar system, commonly referred to as Planet 9, could be causing the Kuiper cliff. The search for Planet 9 continues, and its discovery could shed more light on the mysteries of the Kuiper belt. 33. Kuiper belt object tidal evolution. Reshaping orbits. The gravitational pull of other objects can cause Kuiper belt objects to change their orbits over time, a process known as tidal evolution. This phenomenon can cause objects to collide or be ejected from the Kuiper belt altogether. However, recent research suggests that tidal evolution may also play a role in shaping the orbits of objects in the belt, with some objects becoming locked in stable resonances with Neptune. These findings could provide valuable insights into the dynamics of the outer solar system and how it evolved to its current state. 34. Kuiper Belt Object Trojan Asteroids. Did you know that there are objects in the Kuiper Belt that share the same orbit as Neptune? These are called Trojan asteroids, and they are fascinating objects that can tell us a lot about the history and evolution of the outer solar system. While there are only a few known Trojan asteroids in the Kuiper Belt, researchers are working to find more of them and study their properties. 35. Kuiper Belt Object Color Gradients. The colors of Kuiper Belt objects can provide valuable information about their composition and history. Recent research has revealed that there are color gradients present in the belt, with redder objects closer to the sun and bluer objects further out. This could be due to the effects of radiation and the solar wind on the surface of these objects. 36. Kuiper Belt Object Exploration Technologies. Exploring the Kuiper Belt is no easy feat, given its vast size and distance from Earth. However, scientists have developed a range of technologies to help us study this enigmatic region. One such technology is the New Horizons spacecraft, which famously flew by Pluto in 2015 and is now on its way to study a Kuiper Belt object known as 2014 MU69. 37. Kuiper Belt Object Spectroscopy, Unveiling Composition. Kuiper Belt objects come in a variety of shapes and sizes, but their compositions are still a mystery. Spectroscopy is a powerful tool that can help us understand the chemical makeup of these objects by analyzing the light they emit or reflect. By studying the spectra of Kuiper Belt objects, scientists can identify the presence of different elements and compounds, giving us clues about how these objects formed and evolved. 38. Kuiper Belt Object Mass Estimates. How much do Kuiper Belt objects weigh? That's a question that scientists have been trying to answer for years. While some of the largest objects in the belt have been measured, many others remain a mystery. However, recent research has suggested that it may be possible to estimate the masses of these objects using a variety of techniques, including gravitational perturbations and occultations. 39. Kuiper Belt Object Retrograde Orbits. Did you know that some Kuiper Belt objects orbit the Sun in a retrograde direction? This means that they move in the opposite direction to most other objects in the belt. Researchers are still trying to understand why these objects have retrograde orbits and what implications this has for the history and evolution of the Kuiper Belt. 40. Kuiper Belt Object Thermal Emission. Heat Signatures. Have you ever wondered how scientists study the temperature of Kuiper Belt objects? One technique is to measure their thermal emission, or the heat they radiate. By analyzing the infrared radiation emitted by these objects, researchers can estimate their temperatures and gain insight into their physical properties. If you enjoyed from this video, please don't forget to like and subscribe our channel for future interesting videos. Thanks for watching.